Hola, my name is Pamela. Welcome to my channel. Today I'm gonna talk about the density or a specific mass of a body is its mass per unit volume, and it is expressed in grams per cubic centimeter or kilograms per cubic meter. Since density varies with temperature and pressure, in the case of gases, it is specified for a base value of temperature, which in liquids is 0 or 15 Celsius degrees, and in gases 0 Celsius degrees, and for a standard value of pressure, which in gases is 1 atmosphere. Relative density is the ratio for equal volumes of the masses of the body, and of water at 4 Celsius degrees in the case of liquids. And in gases, the relationship between the mass of the body and that of the air under normal conditions of pressure and temperature, which is at 0 Celsius degrees and 1 atmosphere. Relative mass has no dimensions. In addition to being the density of water at 4 Celsius degrees of 1 gram per cubic centimeter, the numerical values of the relative density of a liquid coincide with those of the density. Specific gravity is the weight of the fluid per unit volume. Therefore, between the specific weight and the density, there will be the relationship that you see on the screen, being G, gravity. If the specific gravity and density refer to water in the case of liquids or to air in the case of gases, that is, the relative density, since G has the same value in the place where the measurement is made, it will turn out that the specific gravity will equal to the relative density, and for this reason, they are usually taken as synonyms. Other units of measurement for density are the next ones. These are the API grades used in petroleum products, which are standardized by the American Petroleum Institute. These are the Baumé degrees, used for acids, syrups, etc. These are the Brix degrees, used almost exclusively by the sugar industry, and they represent the percent by weight of sugar in solution at 17.5 Celsius degrees. In industrial processes, density is a vital variable to measure, as in the case of determining the concentration of some chemical products such as sulfuric acid. The exact measurement of the flow rate in gases or vapors that is influenced by density, the measurement of density in a final product that guarantees the quantities of ingredients that intervene in the mix, among many others. There are several methods to measure density, and among them are AEROMETERS, of which I will talk about in this video, differential pressure, displacement, refractometers, radiation, boiling point, ultrasonic, inertial, Coriolis, and balance. The aerometers consist of a float weighted at the bottom with a graduated upper stem. The device immerses itself until its weight is balanced by the liquid it displaces. The more it sinks, the lower the density of the liquid is, and you can graduate it from any of the units I mentioned. By incorporating a variable inductance transducer with the fixed armature at the bottom of the float and with the coil arranged outside the container, it is possible to electrically transmit the density at a distance, as long as a constant height of the liquid is maintained with an overflow. A variant of the previous aerometer consists of a float with a chain-shaped ballast attached to the fixed point on the container. The float is completely submerged in the liquid, and, depending on its density, it submerges more or less, varying the effective weight of the chain proportionally. A differential transformer captures the position of the float and gives an output signal in alternating current as a function of its displacement, and compensates for the density variations caused by temperature changes in the fluid by means of a resistance probe. The general accuracy of the aerometer is plus minus 1% to plus minus 3%, and they admit maximum service pressures and temperatures of 6 to 8 bar and 120 to 230 Celsius degrees respectively. Viscosity less than 50 centipoise will influence the reading. At higher viscosities or at high flow rates, it is advisable to work with an intermittent flow to capture the position of the flow during periods of zero flow. Their relative density measurement range is 0.5 to 4, and they have temperature compensation. They are suitable for working with clean liquids. And well, this will be all for today's video. Don't forget to give me a like, subscribe, and share. I will upload videos every Wednesday in Spanish and every Friday in English. Adiós!